Now, let's talk about something very serious, heavy duty, right here, okay, which is SD. That's right. SD stands for standard deviation. Now, then first thing we have to consider was mean value, which is we have two different means right here. Okay, so that's in statistics, okay? So outside, maybe we have so many means, right? So arithmetic mean, so geometric means, so harmonic means, and things like that. But we're talking about here only, okay, so arithmetic mean, but still, okay, we have two different things right here. Okay, so right here, population mean and sample mean. Okay, sample mean means like this one up here, only 10 maybe, out of millions of people, right? Population mean is for everybody, okay, like a whole nation, maybe like all females in the United States, things like that. Okay, but, okay, population mean is almost impossible, okay, so, still talking about a population mean, which is we use, for this one, we use mu. Okay, sign looks like this one. The symbol, okay, so mu. We read this on mu, okay, for the length, actually, in metric system, so we call mu, so we call actually micron, okay. So micron means over there, so 1 meter divided by 1 million, which is a micrometer. But here, so we read this one mu, okay. So now mu means what? That's right, population mean. Okay, now what about sample mean? Oh, just like up here, okay, so x, then line on the top. Okay, very simple. Okay, so which is in this case 141, but you add everything, divide by how many numbers? That's it. What is the symbol for addition? That's right, the sum, which is we call sigma, right? Okay, sigma. Okay, usually we can use I. I can be 1 through, in this case 10, but okay, so many numbers we selected. That's why we call sample. See, we just sample, which is the n numbers. Okay, then we use okay, x1, x2, x3. So keep changing. That's why xi. Okay, I can use I. So 1 through n. Okay, changing. Then this is sum, right? Add everything, divide by what? How many numbers? Which is n. That's why I can say 1 divided by n. The same thing. Or you can use this one divided by n. Okay, doesn't matter. Okay. Okay, population mean. Okay, the same thing. So we have to sum, which is add everything, right? Okay. So then we can call same thing. So I equals 1 through n, but this n, oh, that's right, it's a huge n, right? So usually we use a capital letter, n. Okay, then x, same thing. So I keep changing, x1, x2, x3, so on. Now, so same thing. So divide by n, which is a huge n, usually, which is impossible anyway. So next thing we have to think about is after mean, we have to get variance. Okay, variance. Very important things right here. Okay, population variance and sample variance. Okay, the same thing. Okay, variance sign. Okay, so looks like this one. Okay, so lowercase sigma. Okay, sigma looks like this one. Looks like V, but on the top, like some curvy, okay, things going on right there. Okay, so I'm going to try one more time, just like this. Then goes like this one. Okay, so equals, okay, actually square. Oh, that's important part for that. Okay, so that's a variance. Okay, population variance. But what about sample variance? Oh, we use S right there. So which is S square. The same thing, but different symbol. That's it. Okay, for this time again. So we're going to add all sum. That's what we need, okay? Sum, that's right. I'm going to use this one, sigma again. Okay, sigma. I is 1 through, which is how many? In this case, actually, n, right? Okay, then actually addition of xi, you remember x1, x2, x3, minus, okay, which is mu right there. Ah, that's right. See, mu. Then square. Then divide by how many numbers? Okay, so, okay, remember that. Okay, say again. That means, okay, mean value right there was like 141 in this case, but this is a little different because this is a population. But in this case, actually, the same thing right there. Okay, sigma. Then I equals 1 through, okay, small n. Okay, so lowercase n. Okay, then xi minus, in this case, x line over on the top. So it's like this one. Then square. See? Remember, mean deviation right there. Okay, so in other words, the deviation score, you know what I mean? You subtract everything. In this case, okay, 137 minus 141, which is -4. See, things like that. Okay, but you subtract. Also, in this case, this one is a population variance. That's why we're going to use divide by what? Okay, so huge N right there. Okay, what about this one? That's lowercase n. Okay, that's the difference. Now, so finally, so we should get this SD. That's it. Standard deviation. So equals, oh, you're not going to take a negative number, okay? Only positive, but square root, then variance. Just like this. That means, wait a minute. So you remember variance was a square shape like this? Okay, all you need just to take square out. Oh, that's right. So we just take this square out, okay, just like this. Then you just put positive and negative, but like I said, don't take negative. So you just take a positive, right? So you just put square root sign over. That's it. See, just like that. Ooh, great. What about this one? Same thing, just the S, okay, which is sample standard deviation, okay. So which is just the positive. Then you take just square root sign over this. Here we go now. Okay, so one thing very, very important out of this whole chapter. So that's what this N is right here. Only for sample, okay, standard deviation, okay, which is S. Not this one. Don't worry about this one. Population, that means a whole nation, okay, everybody, right? Okay, but in this case, we pick up. The problem is, say, 142, 138, 143. So all this get data right here. So we picked, okay, so we made the samples. That's why we human beings, we have mind, okay, so we pick up something closer to that mean value anyway. That's why this value can be very small. So to make sure, okay, that kind of a deviation, so we can make, okay, that kind of error. That's why to make sure, okay, this one has to be -1. Okay, wait a minute. That means n is not anymore n minus 1 right there. So that means, okay, let's say this one should be 10, but now it's 9. That means, okay, whole number going to be a little bit bigger. That means we just give a slack, like, you know, we give enough room for that, okay? So make sure, okay, standard deviation going to be a little bit bigger than, okay, that original thing because of human error. Okay, so make it simple. Okay, so sample standard deviation. This is for sample standard deviation, which is like a small s right there. So that means, so we just use n minus 1, not n, okay? So that means we call actually, so biased. Biased means like a human mind actually involved. So this one just like shifted to that closer to mean value, okay? So that's why. Okay, so make sure, remember this one, not always, but most hospital, maybe medical field, So they use n-1 techniques. That's up to totally up to that hospital or some place, okay, or your boss. On the next video, so we're gonna try some samples, okay? That's it.